shut this down for a sec. Shut this down for just a sec. The median is the middle, and I want to reaffirm what Davis said because it's important. It's the center or middle, and I'll use middle. I like the middle idea. It's the middle of the ordered data. It's the middle of that ordered data. And the ordered is the important thing. It has to be in order. Otherwise, you're just picking some random value that might be completely inaccurate as far as what typical goes. So I've given you an idea of when you want to use average and when you want to use median. Like if we're talking about very variable house prices, the median might be a better indicator of what's actually going on. If there's a great deal of it. We'll come back to that. We'll go back to that in case that doesn't make any sense. Last but not least, the mode. The mode, we've heard of this before. Tell me your name.
Dylan.
Dylan, go.
Most common.
Most.
Yes. One of my students made up the term mostest. It's the mostest. I love that. A couple years ago, I never forgot that. Somehow that stuck in my mind, the mostest. It is the most commonly occurring data point, right? Right? It's the most commonly occurring.
That's what you should expect to get your house for.
In some cases, yeah. I mean, especially in neighborhoods where they build a lot of the same style. I mean, those houses should essentially sell for almost the exact same.
If you build $1 million house in the middle of like $200,000
Don't expect $1 million. Expect the mode, right? I see what you're saying. Or expect the average or the median.
Yeah.
More like the median, right? Good point, Scott. And there's really no mathematics involved in this other than just looking and counting. I mean, honestly, you just have to go look. So let's go look. Look at our data again. Do we have a mode? Do we have one?
Let's see.
We've got at least two, it looks like. Oh, we have 7 threes. No, we have one. This is a fun data set. There are 6 twos, 7 threes, 5 sixes, 5 fours. Isn't that cool? Now, only one of them showed up the most, and it was 3. 3 showed up the most, so your mode becomes 3. People could argue that this should be a bimodal or a 2-mode distribution because there are 6 twos and there are 7 threes, and that's pretty damn close. It's a good argument. But to make you guys happy and to put your minds at ease looking for modes, just find the one that shows up the most. And this one is 3. Go ahead, Michelle.
Okay, so what if there were 7 threes and 7 fours?
Then we'd say 3 and 4 were the modes. There are 2 of them. You can have more than one. You can totally have more than one mode. You can.
Wouldn't it be 3.5?
No. By definition of how we deal with mode, we don't do that. We just say there are more 3s and 4s than anything else. Yeah, and that's why it gets tricky because there are almost as many 2s as 3s. Some statisticians would call this bimodal. Okay? I mean, to make your lives easy, go to the data set, find the one that occurs the most, and call that the mode. Go ahead, John.
What if there wasn't a reoccurring?
That's okay too. Very good. Hearing all the good questions. We said it's 3, right? What if nothing repeated? What if every single one of the 36 people in the room had a different number of keys? And there's no mode. Or some people will say that they're all modes because they all happen once. That doesn't usually happen. Usually there's a lot of repetition with the with data, or at least a little bit of repetition. Is that fair? How about the other class? Since it's so quick to do.
3.
Look at all those 3s. It's got to be 3, yeah?
It's probably
They have 8 3s, yeah, and there's nothing else at the bottom that even comes close. There's 6 4s. So, pretty slick, huh? Pretty slick. So, I mean, variability, but also some commonality in there as well. Answer me questions right now if you've got them. Please, David, go.
So we went from between 4 and 3 and then 3.5.
We did. Will that always happen? Will that always happen? Will it always go average, median, mode, descending?
Always is a pretty strong word.
It is a pretty damn strong word, but the thing about, thank you, Faith, yes. In statistics, always is almost always an impossible word to use. In mathematics, though, not so much. Like in mathematics, I remember working with a pre-algebra class years and years ago, where I had them measuring the distance around circular things like that.
Yeah.
Like a water bottle, measuring across, and then measuring around and then measuring across. And then I'd have them measure a different bottle, and say a bucket, and I would have them divide those 2 numbers. And they'd say, it's coming out to be like 3.1, 3.2 every time. And my question is, will it always be that way? And the answer is yes, it will always be that way because that's what pi is. The number pi is exactly that number. So mathematics always can be used quite a bit. In life, though, with data that is so variable, it's really hard to say it all. And I can tell you right now, it won't always be like that. And we're going to get into that in about 5 minutes, if you don't mind. Great question. Always is a very tough word to use statistics. Go, David.
Because you were saying that on an average, we would have a 99.
Yes,
and
sir.
a 0.
Yes, sir. Yeah, and that would make the average even further away from the median.
Away, yeah.
Exactly. But if you flip the data over, the mode could be higher than the average. Right? If you had more zeros, I mean, you could have 8 zeros, and all of a sudden the mode's 0, but the median's still 3.5, and the average tanks. So it becomes a different. Yeah, there's all kinds. And later on in this course, I'm going to have you guys creating data sets. I'll give you things like here's a percentile and an average. Make up a data set so that this works, and you get to create them. You'll all create different ones, which is totally rad. Yeah, Faith, go ahead.
So does medium and the mode tend to be closer or tend to fall in line?
Give me
more?
7.5, 8 minutes.
Okay, sorry.
No, sorry. It's awesome. It's a great question. I want to deal with one thing first before I get into that.
Okay.
And it's the difference. Remember how I had you guys doing distributions versus histograms? I think it was last class. We had raw data like this. And you guys said, we don't like that very much. Well, some of you said you liked it. It was great. But then you said, it's kind of unorganized. It'd be nicer to have it. I think you said, I think you used the word organized, Aaron. You said, if it was organized or consolidated or in order, very often you won't get this. You'll get this. You'll get this instead. So that's what I want to deal with right now. This is the exact same data that you just crunched. But now it's given to you in that form where it's in a histogram or a distributed form.